So, we can now look at the procedure of calculation. Now, delta can be obtained from this sort of a formula. You know this sort of a formula. This is of course latent heat of evaporation. This is an empirical formula. That is why you find this kind of. So, delta you can find out from this, and gamma you can find out from another equation which is 665. This is an empirical equation obtained from psychrometric chart, and P is given by this formula. So, one can obtain this. ES one can obtain at 2 meter height, can use this sort of a formula, empirical formula, not easy to remember, and EA as at that particular at 2 meter height, what is the actual vapor pressure, that you can find out, because RH by 100. So, that is in percentage, so point, it will be fraction of this particular one. This is saturated and this is actual, saturated, this is actual. So, it will be fraction of that. If the relative humidity is 100%, obviously this would be 0. So, this is how one can calculate this out, and then supposing tree radius is 500 meters, 500 meter per. So, A you can find out with known sigma, one can calculate out moisture increase you can obtain, and for all trees you find it out. The moisture content is given by this. This you can easily derive. This you can easily derive. This related to this in kilopascal. It is related to air pressure actually. This you can actually easily derive. Partial vapor pressure. This EA at vapor pressure at that particular condition we can find out. This we can easily derive, because we know that molecular weight of water is 18 divided by 28 molecular weight of water, that gives you 0.622. So, moisture content is defined as the amount of moisture present per unit dry mass of the air, right. So, the related to the molecular weight of this. So, this leads to 0.62, and from ideal gas law this can be, this relationship can be derived. PV equals to nRT. So, partial pressure for all partial, both the partial pressure it can be applied and one can find it. So, change in delta G you can obtain, moisture content, the partial pressure difference or evaporation that has occurred corresponding to delta G you can find out. And once you have found out delta G, moisture content change, this is the specific enthalpy or heat content of specific enthalpy of the moist air. This one 1.01 is the specific heat of dry air, this is specific heat of moist air. So, this total is a specific heat from of course, the latent heat is a equivalent specific heat of Cp of moist air, where this is the moisture content. So, moisture has got a specific heat 1.89 I think it is kilojoules per kg or whatever it is, and this is the latent heat of evaporation. So, latent heat of evaporation divided by specific heat gives you, because this is in, this would be joules per kg per degree centigrade, this is joules per kg. So, this would be multiplied by delta G, that gives you the temperature. So, one can find out what is the temperature change in temperature related to moisture change. Now, this is an elaborate exercise if you are trying to do, I have just told you about the principles so far. Now, supposing I have, this is an example. So, where I will come back to this, but let us see the site first. If I have the site photograph, this is the site that I was talking about, example case. This is the Humayun's tomb, as you see from top, and this is the main tomb. Okay. And if you see this, this exists somewhere away from Safdarjung weather station, which is, this is a flyover passing by, and there is a weather station there, where there are a lot of built up areas. In this one there are so many green, right, so many green. Okay. We will come back to this again. This is how it looks like from the top, and the trees are like this. So, these are all the trees actually, the circle marked, First these are the ones, the circle marked, these are the trees, the circle marked, and when circles are separately isolated, these are the trees, approximately in plan circular crown, circular crown. So, then their sizes can be measured. So, one would see that total number of trees of 5-meter radius were 70, trees of 10-meter radius were 50, and 15-meter were 5, and this is required to calculate sigma. A and B, the moderately atmospheric stability, moderately unstable, this is defined in the same Gaussian model itself. So, sigma y, sigma x are calculated based on this. So, let me go back now. Now, one can measure the temperatures, relative humidity, etc., and keep recording the data through a data logger, right. So, you have a data logger stores this data simply. Now, this is measuring wind speed kept on top of those tomb somewhere. This is solar radiation measurement, what is called a pyranometer. This is for external temperature and relative humidity, thermohygrograph, and this is instrument measured for rainfall. So, any rainfall precipitation, because this was metered for a year, complete year, and this is instrument for measuring vertical solar radiation. This gives you radiation on horizontal plane. This is for measuring on vertical surface. So, this is how it measures on this surface, and this is of course the data logger which will store all the data. So, if you store all the data, this is how it is looks like: spring, summer, autumn and winter. It was measured throughout the year. So, typical ones are taken. Now, the dark one also we collected the simultaneously, data were collected from the newspaper. Safdarjung airport data is available. Two stations are there in Delhi, one is Palam, another is Safdarjung. So, data are available. So, this is Safdarjung data, temperature data, and this side is date wise, 1st February to 27th February. This is a mean temperature data, and then this is Humayun's tomb maximum and not this is the minimum. So, this is Safdarjung maximum, Safdarjung minimum, and Humayun's tomb maximum yellow color, and Humayun's tomb minimum is green color. So, you can see the temperature of the Safdarjung station was higher for all the days. If you come to summer, they are similar, but generally lower temperature is somewhat, the pink one is a Safdarjung. So, diurnal variation was more for where you do not have trees. Tree moderates the diurnal variation, that is what you can see. If you see autumn, this is much higher, this is much lower, and this is month of August. Now, August means rainy season in Delhi, right, relative humidity will be different, and the bottom you can see that green color is the Safdarjung airport, I mean the pink is Safdarjung airport, and this is the Humayun's tomb. So, there is a difference as you can see from this. This is for winter, same. So, temperatures you can see there is a it moderates the temperature, there are so many trees actually moderates the temperature. And if you look at temperature of this 2-1, this is actually mean temperature of this 2 for days wise is again there. So, sorry, this is relative humidity, not temperature, this should be relative humidity, this should be relative humidity. So, relative humidity comparison from time of every day mean relative humidity, you will always see the relative humidity actually Humayun's tomb is pink, it is higher, relative humidity Humayun's tomb is pink and Safdarjung is blue or whatever it is. So, generally this is higher or same. So, it causes increase in relative humidity and decrease in the temperature, right. So, maximum temperature of the microclimate is less than that of the macroclimate. So, Safdarjung can be considered to be a macroclimatic scenario, somewhat general Delhi scenario. At the same time, the minimum temperature of the tomb is more than that of the Safdarjung tomb. So, microclimate, this difference sometimes as high as 4 degrees centigrade. So, this kind of that many number of trees, 5 15 meter trees, 50 10 meter trees and 75 meter dia trees, they could reduce down the temperature by 4 degree on an average over the space that we considered, and we can see there is a similarity of pattern of relative humidity. Relative humidity tend to actually increase. So, therefore, they bring down the temperature, but increases the humidity. This is what is been shown. This is what this is what you can see. This is the trees are. So, these trees are modeled in this manner. Trees are modeled using this same model that I talked about, and yeah, temperature is the same thing again shown here, right. So, there is less than 3% absolute error from measured value minus calculated value. One can calculate, estimate this measured values were available to us, but we could calculate it using the model that I talked about. First, you find out the evapotranspiration for the given type of plant trees which are there, and they were all similar kind of trees. Multiply that by the crop factor, etc., and then use Gaussian dispersion model to find out the moisture content in the volume that you have taken. And what we find is that model predicts the measured temperature relatively well. So, that is what it is. So, however, it is within the range of 1 to 10, hence it actually is acceptable. One can actually calculate out the energy saving because of this. Supposing I calculate out the annual energy consumption using some, here of course, we use a software, open source software like EQUEST. Those who are interested can look into the software. It is open source software, developed in US Department of Environment, DOE 2. So, you can use this, and if you calculate this out, it will show you that hourly data provided by climate design, etc., they convert the Humayun's tomb, which is at 5-minute interval, okay, etc., for some only maximum and minimum temperature of a day is given. So, one can compare the minimum daily temperature through a chart. For example, there is a chart available in Kinisberger's book. If you know the minimum temperature and maximum temperature, assuming a sinusoidal variation, one can find out what will be the hourly temperature. This is very simple. It is not very, see, because T max minus T mean multiplied by sin theta, theta is basically T, you can say T multiplied by 1 by 24 into pi, 24 into pi. Pi corresponds to 2 pi corresponds to 24 hours, pi by 12. 24 hours is a full cycle. So, one can consider sinusoidal variation of temperature, and this can be obtained because the meteorological data available were only maximum and minimum. So, one could calculate out the heat load, cooling load for a building located close to that environment, and one could calculate out the cooling load that can be there if the building was close to all those that many number of trees. And it shows actually just for 5 days it has been done. So, it would show that the temperature actually for Safdarjung airport is this color, the Humayun's tomb is this color, and this is the one one is the some data for 5 days from the software that was used. So, one would give, there is a Humayun's tomb temperature, peak temperatures are down and minimum peak is also raised because diurnal variations are lower. So, by even doing a kind of a energy calculation for buildings located in these two areas, this can show that there is a lot of energy saving. So, one can find out the quantity of the temperature variation. This is for Humayun's tomb, the pink is for Humayun's tomb, this is for Safdarjung airport. The temperature actually reduces down, and this is how the building that is modeled, existing hourly temperature etc. from the data data that is available, and it would show you that there can be actually an energy saving. So, this is the software output actually shows that electricity consumption actually would get reduced if you plant that many number of trees, right. So, this one is total electricity consumption kilowatt hour from the software that was used. So, this component shows space cooling, this is space heating if required, different month December. So, you can see that in May, June you have got a lot of heating, cooling you might need in the night depending upon the situation and the temperature that you have maintained inside the room. So, yellow one is lighting and task lighting etc., etc. So, it gives you all those. So, you can see that the comparison would show that actually there can be a saving in the energy if you have actually planted those trees, right. So, there can be reduction in this. So, annual energy consumption using Humayun's tomb bin file, and this is the consumption Safdarjung file. If I use those, then I find the values are somewhere 300 and something, peak is 300 plus something. Let us see how much is this here. This is 200 and something. So, there is a saving in energy if you plant that many number of trees. There is a saving in energy if you plant that many number of trees, etc., etc. So, this is related to how trees affect. Now, doing this exercise of course, is a significant time would be required, but I have just given you the principle which you can understand, and this also shows through a demonstration exercise that you can actually reduce down the cooling load. You can actually reduce down the cooling load, but there is a negative effect as well. If you do too much of greening, we will have to see essentially if it is everybody is using an air conditioning system, an active cooling and heating system, then planting tree has got a meaning. It would actually reduce down the energy load. But if the society is changing in a way, say, and you have planted a lot of trees, what will happen is earlier when it was dry summer, people were using more of what is called a desert cooler. Now, as the humidity increases with this, you can't use desert cooler anymore. So, because desert cooler is ineffective, which uses evaporative cooling, dry air comes through it, absorbs, dry air comes through a fan drives it, exhaust fan drives it, and you have got finely divided water particle which evaporates, and latent heat of evaporation it takes from the same air itself, it sends cool air to the room, which will consume around 200 watts and not more than that. So, if your humidity increases, this becomes ineffective because air is no longer dry. So, in such situation, in fact, your cooling load will increase because people will tend to use the air conditioner if they have the purchasing power, of course. So, in a society which has got which is somewhat affluent, earlier they would have been doing with a desert cooler, now they will all change over to air conditioning, which might actually complete city, if you look at it, it might increase your energy consumption. So, the other social aspect is there, but already people are using, let us say, air conditioner. Now, you have planted a lot of trees, obviously cooling load will come down, or commercial places cooling load will come down. So, this must be looked into together with the social situation as Okay, quickly the last part of our discussion is surface water balance, a few slides. We can see that because you do water harvesting, you would like to utilize the water as much as possible, very first slide that I showed you. So, if you see the surface water, these are the streams or rivers, this is the rain, precipitation or snow that could be there melting and rivers coming in. Now, some would get vaporized, some goes to the subsurface water, groundwater, right, and finally water goes to the ocean and sea. So, that is the basically water balance, right, and subsurface water also finally reaches the ocean and sea. So, runoff is R, P is the precipitation, E is evaporation. So, if I am trying to do a balancing, G is the groundwater recharge, I is imported water because the city will import water, right. City Delhi imports water from Ganges in fact, besides Yamuna. Yamuna anyway is a part of it is flowing through it, but it imports water from Ganges canal, because there is a upper Ganga canal, and this is Muradnagar near to, as you go towards Hardwar, there is a place called Muradnagar where there is a water intake. From there they actually from the canal they get the water. So, imported water. F is the water from chemically after combustion. So, if the factories are there or any other combustion, water vapor will be released, and soil water. So, delta is advection, any kind of discontinuity of moisture, basically flow through porous system, there can be advection or diffusion of moisture vapor can also occur. So, this is the kind of an equation, precipitation plus imported water plus water formed chemically, that is added to the moisture vapor added, must be equals to evaporation, E is the evaporation, this is delta S actually, G is the groundwater recharge. So, delta S is the storage, delta is the storage in the aquifer or something of that kind, and delta R is runoff, which we will like to minimize, because all others are useful, runoff is quickly going. So, this is the diagram, this diagram shows you, the precipitation equals to evaporation plus storage plus groundwater recharge plus runoff. So, surface evaporation, root zone, G is the groundwater recharge, delta R is the runoff what is coming out, coming in, coming out. So, in rural area of course, and this is the stream, the precipitation is here. Urban area, this is also be added, this is F through combustion, right, this is F through the combustion, vehicle also moisture evaporation occurs. Delta S is the storage in the system, urban system I am talking of, P is the precipitation, and this is how, this is the equation that I showed you. So, minimization of delta R is a good option, because that is not getting utilized. G and delta S can be increased, G is the groundwater recharge, and storages if required would be E reduces the temperature. So, R is the thing which is not useful. That is why if you see any rating, energy and environment rating, they would talk in terms of groundwater recharge and so on, right. Okay. So, this is what if you look at the rural and urban scenario, here 5% runoff where you have a forest, 45% evaporation, precipitation is what is charging it actually. If you have low plants, 40%, 15% is runoff increasing, and residential with lot of greenery is actually 30%, and too much congested commercial areas etc. 60% is runoff, right. 45% goes to percolation to the ground, 45%, 50% here, 35. So, this is how actually it occurs, and that is why utilizing the water as much as possible other than runoff, that is the best option. Okay, I think that ends our discussion.